Welcome everybody to Redstone class number 2. This one's about basic logic gates, which I think is where Redstone gets really interesting. If you missed the last class, we have it posted up on YouTube, so you can watch that, and you can always come here and check out the circuits over in that direction. Today's class, like I said, is on logic gates. Logic gates are what makes your computer work in real life. They're built out of transistors. But what's cool about Redstone is you can build all of these logic gates with the Redstone in Minecraft, and you can start to make some advanced circuits that do some really interesting things. So today I'm going to show you the basics of those, the basic gates, and then you can eventually put those together to make more advanced circuits. So the first thing to understand about logic gates is they work off of what's called a digital circuit. A digital circuit has ones and zeros, meaning it's on or off. And so if you notice with Redstone, most of the wires you look at and you're like, well, that's on or that's off, or the torches can be turned on and off. So it works really well in these digital circuits. What a logic gate does is it takes a couple input signals, one or more, and it gives you a certain output signal. And the difference between the gates is that each gate gives different outputs for different inputs. Does everybody kind of understand that? We take inputs, we do something to it, and we get an output.
Yeah.
Yep.
So the way to read those inputs and outputs in real life, we use what's called a truth table. If you look these circuits up on Wikipedia, or if you look the Minecraft Redstone version up on the Minecraft wiki, there will be truth tables on all of those sites. So I thought I'd show you how a truth table works to show you what they mean. So this is an example of a truth table. If you see one in a book or online, they'll use the number 1 to represent an on signal, and they'll use the number 0 to represent an off signal. Here I've used redstone lamps that are on and off. So on the left side we always have the inputs, and on the right side here we have the outputs. This truth table is showing what is called an AND gate, which I'll show you in a second. Now the way an AND gate works is you take 2 or more inputs. In this case I made the truth table for 2 inputs, and it gives you a certain output. It's called an AND gate because both of the inputs have to be on. So input A and input B has to be on for you to get an on output. So this truth table is showing that. The top 2, we have both inputs are off, so the output is off. If you only have one of the inputs on, the output is off. But if both of the inputs are on, the output is on. So that's a basic logic circuit. And this is how you would read truth tables to learn what a logic circuit does. So if you come up with some idea for a redstone game or some circuit that you want to do to make a door open, but you realize that you need some sort of logic gate, you could figure out what you want it to do. So say I want that door to open when one switch is on and one switch is off. You could then look up the truth table for that on the Minecraft wiki and know exactly how to build that gate for it. Does that make sense to everybody?
Yes. Yeah.
Yep.
Alright, so over here I'll show you some of the basic logic gates. There are probably at least 20 different ways to build every one of these gates, so I've just given an example of each one. What I want you to get from this is not how to build the gate, because you can always look that up on the wiki. You can ask somebody that does it pretty often. I had to look up some of these on the wiki, so I don't remember how to build these, but I know what they all do, and that's the important part. So I know if I'm building something and I want it to perform a specific action, I can look up which gate I need and know that I'm looking up the correct gate. So the simplest logic gate is this one right here, which we saw last time. It's called the NOT gate, or the inverter. All it does is it takes a signal and outputs the opposite of it. So its truth table is really simple. It would only have 2 columns in 2 rows, and when one is off, then the output is on. When the input is off, or when the input is on, the output is off. Does that make sense?
Yeah.
Yep.
Now as we move up more to other types of gates, most of these use 2 inputs. You can always add more inputs to these. So you can have, for example, this is an OR gate, and I'll show you we can do OR gates with 3 inputs later. An OR gate takes both inputs, and the output will be on if any one of the inputs or if both of the inputs are on. So you can go ahead and try the levers and see the lights on if either one of the levers is on. So if lever A or lever B is on, the output is on.
User joined your channel.
The next one's the AND gate, which is what we did the truth table over there for. Remember this one, the output is on only if the input A and input B is on. So now you can test that, and notice how the levers here correspond to the inputs on the truth table, and then the light here corresponds to the output on the truth table. So does everybody understand how an AND gate works?
Yeah.
Yes.
Yep.
Okay.
When we were at the OR gate, you said one of them has to be on, but
Yes.
when both are on, it still works too, right?
Yes.
That's the case on the lowest thing on the truth table.
Yes. So either one or the other one has to be on. Both can also be on, and it works. We can also invert each of these simple gates. So over here, I have what's called a NOR gate. What that stands for is a not OR gate. So it's an OR gate, but it outputs the opposite of the OR gate. So before anybody messes with the switches, what do you think should happen if it's a NOR gate?
It should be on when both are in the same position?
Pretty close.
It should be on when nothing is flipped, right?
Right, exactly. So it's the opposite of the OR gate. Remember, the OR gate lights up every time one of the switches is on, but it's off only when both switches are off. So the opposite of that would be this light is only on when both switches are off. But if you turn any of those switches on, or both of them on, this light will be off. So everybody understand how you can invert another gate?
Yes.
Or what that means?
Yeah.
To invert a gate, it's pretty simple. We're just combining that first inverter, the NOT gate, with the OR gate. So you see this OR gate just has simple wires going into it. All we did for the NOR gate is we took the torch here that makes the NOT gate and added it to the end of the OR gate here, and that makes it a NOR. We can do the same thing for the AND gate here. So that's called a NAND gate. Again, we put the N in front to mean not AND, and it works the opposite of the AND gate. So remember, the AND gate is only on when both of the switches are turned on. So in this case, the AND gate should always be on, except for when both of the switches are on. See that? Alright. There's one more variation that we can do to gates that we often see in the real world, and that's an example that I've shown over here. So this is called an XOR gate. What the X stands for is exclusive. So this is called an exclusive OR gate, or an XOR. Now what this does is it's like an OR gate. Remember, the OR gate turns on if A or B is on, or if both of them are on. Exclusive OR means it will only turn on if A or if B is on, but not if both are on. So if both are off, or if both are on, there won't be a light. But if one or the other is on, there will be a light.
That's cool.
So you can also make exclusive AND gates, and you can make exclusive NOR gates, so you have XNOR. So you can combine all these gates into other more advanced gates. Does that make sense? Right. Just by combining all the different gates. And that's why Redstone gets really interesting, and you can build these complicated circuits. It's just by combining all of these simple little gates together. So I wanted to show you two more circuits down here. These would technically probably be called memory gates. It's just a more advanced form of a logic gate, where you have input signals and output. These are sometimes a little more advanced, but I wanted to show them to you because I think they're two of the most useful circuits in Redstones. So this one is called an RS latch. RS stands for reset set, So this is a memory device, which means it will store a signal that you give it until you reset it. That's where the S and the R come from in the RS latch. So right here, this button is the set button. So when you flip this button, it will give an on signal. So you see how the light is on? And that light will stay on until you reset the latch, which is that button. Does that make sense? So you can store a signal if you want for a long period of time until you reset it.
So possibly you could make a door stay open until you're and leave again, and then only. But you have to reset it.
Right.
You can't reset it on the same button, right?
In this case, you can't. There are other items that do that. So, for example, this would be an example circuit that would do that. This is called a flip-flop. There are a few different types of flip-flops. This one is called a T flip-flop, which stands for toggle flip-flop. All it does is it basically makes a button work like a lever. And so each time you hit the button on the side of that blue block, this light will turn on and then off. Unless somebody was messing with the... Alright, try again. There we go. Somebody put an extra item in the hopper. So this makes a button work like a lever. Now what's neat about this kind of circuit is this is easy to wire up. Say in your house you have lights or you have a door. You could push the button on the outside and it would open your door. Or when you walk in one door you could push a button and it turns on all your lights. But you could send a single wire under the floor in your house to a button on the other side of the room. Say you have a back door to your house. And so either button could turn on or off the lights. And that would be an example of using this gate. Does everybody kind of understand this one?
Yeah.
Yes.
At least what a toggle flip-flop is.
Yes.
Now, like I said, all of these circuits can be built in many, many different ways. We have some examples in the room over there. You see the chests on the blue wall? So if you ever want to come and see some of these circuits, we have a bunch of examples of them in here. So you might have some size constraints, or T flip-flops are really easy to build with pistons, but pistons are noisy, so a lot of people try building other T flip-flop circuits.
And now that we have hoppers, it makes it easier.
Right, hoppers make very easy flip-flops. Sure. So the way that flip-flop works is, do you know how the comparator works? A comparator, it looks like the looks like a repeater, but what it does is it'll tell you if you have any items in a chest or anything with an inventory. So since these hoppers have an inventory, this comparator will emit a signal if that hopper has an item in it. So if you look in that hopper, there should be a sword in there. And see, when you take the sword out, the comparator doesn't light up anymore. So the way this flip-flop works is both of these hoppers are pointed at each other, and each time you push this button, it makes that item move from one hopper to the other hopper, and it goes back and forth. And so when the item is in this hopper, the light is on, but when it's in this hopper, the light is off. Right, exactly. That's what makes it toggle. So another T flip-flop you can use would be, like inside we have one of these circuits where you have a piston that pushes a block, and remember you can power through blocks. So you could have, let me build a real, show you right here. So let's say I'm a piston right here, and you have a circuit that's lighting up right there. If I push this block in front of there, that block is now powered, and say we have a lamp. See how the lamp is powered? But without the block, it's not powered. So you can do a T flip-flop with a piston, where you would push the you would take the piston and make it push over this into that thing, and it would turn on. And then when the piston pulls back, it would turn off. So does everybody kind of understand how these basic circuits work?
Yeah.
Yep.
Yes. Yeah.
Alright, now I have a little exercise for everybody to try and take one or more of these circuits and put them together to see if you can build a little device. And so what I've done over here is I've built a mini example of what you can do with these. So I'm sure a bunch of you have seen like spy movies or I don't know, other kinds of movies where people are trying to launch nuclear missiles and you have to have two people turn the key at the exact same time to launch the missiles.
Yeah.
Well, that's what I've built here. So somebody push that button right there. And see, nothing happens. Now if I push this button, nothing happens. But let's push it at the same time.
I need to count down.
Alright, ready? 3, 2, 1. And it works. Or, have you guys ever played Portal before?
Yeah.
Yes. Yeah.
Yep.
So you know in Portal how they have the companion cubes? And sometimes you have to put
Yeah.
the companion cubes on multiple spots to get the door to open so you can go to the next level.
Yes.
Why don't you guys try building a version of a Portal level where you have to put companion cubes down. So similar to this, you'll have to use one of these logic gates to get it to work. So what I want you to do is make maybe a pressure plate or a couple pressure plates and make it so you have to put blocks or make people stand on the pressure plates to open a door or to turn a light on.
You stole my idea.
Everybody think they can try that? Break off in teams and give that a little whirl?
Yes.
Or get creative, make it even bigger. You can try expanding these gates to use 3 inputs. So for example, I'll show you a simple one with this OR gate because it's really easy. This would be an example of a 3 input OR gate where if any of these are on, then this block is on. It's only off if all of them are off. So you could do the same thing with the AND gate where if I added another lever, it would only turn on if all of the levers are on. And so that would be a 3-bit OR gate is what it's called, or a 3 input OR gate. So what I want you guys to try and do is use all of those materials that are stored in the chests on the wall over there and try and build something that uses one of these gates. And then if you need help, I'll be here to give you a helping hand.